Hello everyone, today I'm going to present a study of pre-service Chinese teachers' performance in solving and ranking decimal multiplication and division problems. Before I dive into the study, I would like to explain what motivated me to start this research. I train pre-service elementary teachers in the US, and I noticed my students are struggle with solving decimal multiplication and division problems. They do not know what is the right operation to use, and they don't know which number should go first. For instance, they don't know which number should be dividend or which number should be divisor. So I read some research and find that there are lots of studies reporting students and also teachers struggle in learning decimal, even including the students from the top performing countries. However, decimal are crucial. They are important topics and are foundations for students to learn other subject areas. We decided to focus on pre-service teachers because they are the teachers of the next generation, and their mathematical knowledge is going to be closely related to their students' performance as reported by multiple study. The research also identified that there is a strong relationship between teachers' knowledge of decimal and their knowledge of effectively teaching the decimal to their students. We decided to focus on Chinese pre-service teachers because it has been well documented that Chinese teachers tend to have a robust and profound understanding of the content they're teaching. So we use the mathematical knowledge for teaching framework to guide our study. So there are 6 components of the mathematical knowledge for teaching, as shown on the right side in and add. For this study, we are only going to focus on the subject matter knowledge, and we will try to investigate the common content knowledge and the specialized content knowledge. We have 2 research questions. The first question addresses pre-service Chinese elementary teachers' performance in solving the word problems involving decimal multiplication and divisions. We noticed that the American pre-service elementary teachers struggled with solving decimal multiplication and division word problems. So we want to know how the Chinese elementary teachers perform in this area. So the first question is relevant to the common content knowledge. The second question is asking the Chinese pre-service elementary teachers to rank the difficulty level of the word problems they just solved. So this question is investigating pre-service Chinese elementary teachers' specialized content knowledge. Before I share more details about the study design, I would like to go over a few factors that impact pre-service teachers' performance in solving decimal word problems. The factors include familiarity of the context, type of quantities involved, size and type of number used, and the familiarity of the decimals. Researchers also reported an interesting phenomenon, which they name it as non-conservation of operations. It's basically saying that you have 2 almost identical problems, as shown on this slide about Linda's working speed. The questions are identical, other than the number used there are different. The students will have difficulty in solving the second problem because it involved decimal, but they wouldn't have problem solving the first problem because the numbers are whole numbers. Research has reported implicit model and its impact on students' performance. Implicit models are unconscious and primitive intuitive models linked to each operation. For multiplication, there are 5 models related, but the repeated addition model is the implicit model. For instance, when given a multiplication problem, such as 3 times 0.26, students tend to think this problem as adding 0.26 3 times. However, when the first number is a decimal, such as 0.67, students who's having a strong implicit model as the repeated addition model would have difficulty understanding it because it does not make a lot of sense to add 0.26, 0.67 times. Two models are associated with division partitive and measurement model. Both models tells you the total number of objects. Partitive model indicates the number of groups, but as for the group size, the measurement model tells the group size and as for the number of groups. Students tend to associate certain conclusion with each models. For instance, for the partitive model, students would believe divisor must be a whole number, divisor must be less than dividend, and quotient must be less than the dividend. For the measurement model, students tend to believe the divisor must be less than dividend. All of these incorrect conclusions tend to lead to other commonly held student misconceptions, such as multiplication always makes bigger and division always makes smaller. The participants include 77 Preservice elementary teachers at their junior year. The study was conducted right before the student teaching semester at a Southeast University in China. The teacher education program there represents an average teacher education program in China. The participants were asked to complete 5 decimal multiplication division word problems. After they solved the problem, they were asked to order the difficulty level of the problems and provide the rationale for their ordering. Here is a list of 5 tasks used in the study. It includes 1 multiplication problem and then 4 division problems. The 4 division problems include 2 partitive division problems and then 2 measurement division problems. I try to vary the numbers in the problem. Some decimals are less than 1, some are greater than 1. I would like to see if the types of number had impact students ordering the difficulty level of the problems. The results indicates that Preservice Chinese elementary teachers perform very well in solving these word problems. The incorrect responses are so few, and the majority of them are calculation errors. After solving the problems, teachers were asked to rank the difficulty level of the problems. So for instance, if teacher writes 5, 3, 4, 1, 2, they meant to say 5 is the most difficult question and 2 is the easiest question. So I look at all the students' performance and try to figure out which question they think is the hardest, and they will put on the first position, and which question they felt is the easiest, and they will put on the 5th position. And then I calculate the average position for each question. The results showed that the easiest question is number 2, which is a multiplication problem. The harder question is number 5. An analysis of students' ranking of the difficulty level suggests the most frequent ranking is 5, 3, 4, 1, 2. And then some other responses follows. We can see that question 5 and question 3 were ranked as the 2 most difficult questions, and question 2 and 1, 4 are ranked easier. And question 5 and 3 are measurement problem, and 1 and 4 are partitive division, and question 2 is a multiplication problem. We analyzed Preservice teachers' rationale for ranking. Practical consideration is ranked the highest. For instance, in question number 3, the question asks how many bowls can hold certain liquid. The Preservice Chinese teachers believe that's a hard question because they have to round down the decimal to get the whole number both. Teachers also tend to believe multiplication is easier. Our rationale includes computation, formula, reading amount, the division model, and number of steps. We find Chinese teachers perform well in solving decimal multiplication and division problems. The implicit model that impacts US teachers does not affect Chinese teachers' performance. Chinese teachers can solve the division problems that are not conform to the implicit model. We also notice Chinese teachers tend to rank the measurement division problems harder than the partitive division problem, but their reason is not to attend to the underlying division model, but on the practical consideration. The conclusion is that the Chinese teachers were not aware the impact of the implicit model on the difficulty level of the problem, partially maybe due to their success in solving this problem, so they were not aware that's a difficulty. That's the end of my presentation. Thank you.